From Bloomberg News and iHeartRadio, it's The Big Take. I'm Wes Kosova. Today, mining asteroids for knowledge, and one day for profit.
We copy you down, Eagle.
Listen, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue.
It's been more than half a century since Apollo 11 landed on the moon in July 1969, and it's still a thrill to hear those grainy tapes across time and space. The U.S. and other nations are now working on well-publicized programs to put people back on the moon, and maybe Mars at some point. But there's also a lot of brain power and money going to a whole different kind of space exploration that maybe you haven't heard as much about. It involves sending spacecraft not to planets, but to asteroids, and hauling the precious materials inside them back to Earth. Later in the show, I talk with Bloomberg reporter Lauren Grush all about the fast-growing business of space. But first, our supervising producer and self-confessed space geek Vicky Vergolina digs into the science with the leader of NASA's OSIRIS-REx mission.
This is Dante Lauretta, Regents Professor of Planetary Science and Cosmochemistry at the University of Arizona. I also have the honor of serving as the principal investigator for NASA's OSIRIS-REx asteroid sample return mission.
Can you tell me about the OSIRIS-REx mission and what you hope to learn from the samples you're getting from the Bennu asteroid?
OSIRIS-REx is a mission of planetary exploration in NASA's New Frontiers program. So it's been sponsored by the agency in partnership with the Canadian Space Agency, CNES, the French Space Agency, and JAXA, the Japanese Space Agency. The mission objectives are to launch a spacecraft to near-Earth asteroid Bennu, survey it in exquisite detail, use that information to select a location on the surface to send our spacecraft down and collect material for ultimate return to Earth. The good news is most of that has happened already. We launched in 2016, arrived at our target asteroid in 2018, and successfully collected a sample on October 20th of 2020. The spacecraft departed Bennu in May of 2021 and is currently in interplanetary space en route to the Earth, and those samples will be on the ground on September 24th, 2023. The primary reason we selected asteroid Bennu is because it's a carbonaceous asteroid. That means it's rich in carbon in the form of organic molecules. And Bennu is an ancient geologic remnant from the early solar system. So one of the key objectives of the mission is to understand if asteroids like Bennu may have delivered the building blocks of life to our planet 4.5 billion years ago.
Is this the first mission of its kind? Is this the first time we've been able to actually get samples and reach a near-Earth asteroid?
This is the first time that NASA has flown an asteroid sample return mission. But our partners in Japan, the Japanese Aerospace Exploration Agency, have actually flown 2 asteroid sample return missions called Hayabusa and Hayabusa 2. And they delivered their samples in December of 2020.
Part of this mission, from what I read, is to gain a sense of potentially hazardous asteroids that may be heading for collision on Earth. Is that part of the mission as well?
It is. And by virtue of picking an asteroid that was close to the Earth, Bennu is a near-Earth asteroid. And its orbit is very similar to that of our planet. And in fact, it crosses the Earth's orbit on September 24th, which is why that's the date that the samples are coming home. So we do worry about Bennu impacting the Earth. It is a potentially hazardous asteroid, and in fact, ranked number 1 on the potentially hazardous asteroid list. So another part of our investigation was to understand its future orbit. And you might not think that's a big deal because we understand gravity and Newton's laws really well. But with these small asteroids, the effect of sunlight has a substantial influence on their future trajectory in the form of absorbing radiation. Because Bennu is so carbon rich, it's very dark and black. Think about asphalt, an asphalt parking lot in the summer. It gets really hot, and then that energy is released back into space as thermal energy or infrared photons, and those impart a thrust on the asteroid. In the case of Bennu, it slows it down, which means its orbit shrinks, making it more likely to hit the Earth in the future.
And I understand recently there have been missions where we're actually trying to intercede the trajectory of an asteroid that feels like it's coming a bit too close to Earth. And those missions have been largely successful.
That's right. And especially last year, NASA launched the DART mission, the Double Asteroid Redirection Test, where a spacecraft impacted a satellite of an asteroid. And the reason they chose a moon orbiting around an asteroid, a natural moon, so they could change the moon's orbit without changing the asteroid's orbit, because the last thing you want to do when you're trying to test a deflection technology is actually send something towards the Earth accidentally. So by hitting the moon, there was no chance of any risk to the planet, yet they could see the phenomenal response of the asteroid's orbit to that impact. It was an amazing result, and the first true demonstration of an asteroid deflection technology in space. We're not quite there yet. We don't have the capability to actually deflect an asteroid on a trajectory to the Earth. This is the first step towards developing that technology. What I'm impressed to see is that NASA and the United States government takes the risk seriously, as do many other nations around the world, and are developing technologies to prevent such a disaster. Because if an asteroid were to strike, and I want to remind the listeners that an asteroid did hit the Earth on February 15th, 2013, a relatively small object exploded over the city of Chelyabinsk in Russia, causing massive damage, knocking down buildings and injuring thousands of people. So even the small asteroids can be a problem. A big asteroid will really ruin your day.
Yeah, just ask the dinosaurs, right?
Exactly. In fact, we have a running joke in our business that asteroids are nature's way of asking, how's your space program coming along?
That's pretty good. So I wanted to ask you about the resource identification component of this mission. This is part of NASA's mission to get a sense of what resources are available for potential future mining of precious metals. Can you tell me about that component of the mission? It is in the OSIRIS acronym.
The acronym, yeah. So I wrote that acronym in 2004, and I thought, I'm just going to let my sci-fi geek flag fly. I'm going to put resource identification down there, and someday somebody will look at our data and think about mining this asteroid. But the landscape has changed enormously, and there's been corporate interest in developing the economic resources of near-Earth space. I mentioned that Bennu is rich in carbon, and that feeds our origins investigation, which is the first word in the acronym. But in addition to the carbon, it's very rich in water, which may sound strange because it's a relatively small asteroid, about 500 meters in diameter. And it doesn't have liquid water on its surface, and it doesn't have ice. It's much too close to the sun for that. The water is actually locked inside minerals called clays that formed early in solar system history when hydrothermal activity, like think of Yellowstone, Old Faithful kind of geysers, were active in the early solar system and altered the original rocks into those clay minerals. And that water turns out to be the key economic resource, not to bring it back to the Earth, but what you can do with water is you can break it up into hydrogen and oxygen. And liquid hydrogen, liquid oxygen is one of the most powerful rocket fuels that we know of. So the concept is that you're developing fuel depots in space, and anybody that's pushing out to the lunar surface, to near-Earth asteroids, or deep solar system exploration will be able to refuel their spacecraft not on the surface of the Earth. So you save a lot of launch costs if you don't have to launch your fuel, if you only have to launch your hardware.
I did want to go back for a second to the actual extraction process. Paint me a picture of how you actually get it off the surface of the asteroid, or if you're digging deep into the asteroid.
Absolutely. So it's a spacecraft. So it looks a lot like an Earth orbiting satellite. It's powered by solar arrays. So all the electricity is solar. It's got a giant 2-meter radio dish so we could communicate across the solar system. And the sampling strategy is what we call touch and go, because we're in a microgravity environment. So with that kind of environment, you're not really able to land. I kind of looked at it more like a scuba diver around a coral reef or a hummingbird. You're able to buzz around this thing and take a look at it from all different directions and angles, and ultimately get up close and personal with it. The spacecraft has a 3-meter long robotic arm, and at the end of that arm was a collection head, which was essentially an air filter. And our strategy was to push that filter down into the surface of the asteroid, into what we call the regolith. And regolith refers to the loose blanket of dust and rock on these airless bodies, which is the stuff we want to bring home. And it's kind of like a leaf blower. We just blew down this high purity nitrogen gas. We had 3 tanks, so we could try 3 times, and pushed a bunch of rocks into that filter. And it worked amazingly well. We thought we would be in contact with the surface for 5 seconds. It turned out the surface of Bennu is more like a fluid, and it just flowed away from us, and we sunk down 50 centimeters, right? Like 1.5 feet deep into the asteroid surface, which meant we collected an enormous amount of material. In fact, we collected so much material, we jammed open our check valve, which was designed to keep the sample inside. And as soon as we got away from the asteroid, we saw that some particles were escaping. A major freak out moment for me after our greatest triumph. All of a sudden, all this hard work is now floating away into space. And so we went into emergency mode and rapidly got the sample stowed into a protective return capsule. It kind of looks like a mini version of the capsule that brings the astronauts back. And that is the only part of the spacecraft that will actually make it back down to the surface of the Earth.
I've read the water component, which you spoke of earlier, the water in certain asteroids being almost like a gas station in space, right? Like you said, it would allow for hydrogen and oxygen to be broken down. I mean, I imagine you could distill it for even drinking, but it really allows you to go much further into space. Do you see that as the next necessary component to get further out into space for human missions?
Absolutely, for several reasons. One is you really don't want to launch your fuel off the surface of the Earth because that's the most expensive part of your mission, is lifting mass from the surface of the Earth into Earth orbit. Once you're out into the solar system, you actually don't need a lot of energy to move around. It just takes time to get to these distant locations.
AstroRank is an organization. They rank asteroids in terms of cost efficiency, both how close to Earth they are, as well as what minerals and precious metals are in there. But they had said that the top 10 most cost-effective asteroids would produce around $1.5 trillion of material. Can you talk a little bit about what materials are in there?
So most asteroids are not hydrated or rich in water like Bennu and Ryugu, which was the target of the Hayabusa 2 mission from JAXA. Most of them are metals and stony materials. The metals are dominated by your base metals: iron, nickel, cobalt, chromium. So you could make steel, a lot of steel in space. The basic components for steel making are out there, and that gets you all kinds of structure and capabilities. And then you're right, the platinum group elements, platinum, rhenium, iridium, osmium, very rare and precious on the surface of the Earth, are present in high abundances.
What are you hoping to find from the samples when they return?
Clues to the origin of life. Full stop.
We'll leave it at that. Yeah. Well, thank you so much. I really appreciate your time, Doctor.
My pleasure.
When we come back, a company with its eye on mining asteroids for lucrative metals. Okay, we've heard about the promise that NASA and scientists see in asteroid missions. Now comes the inevitable question: is there money to be made from mining asteroids? The answer is yes, but to explain, Vicky rang up Matt Gailich. He's the co-founder and CEO of AstroForge. That's a company that aims to mine asteroids for materials like platinum, iridium, and palladium. The so-called platinum group metals we're going to need more and more of for electric cars and other technologies. That, of course, will be no easy task, and Vicky asked him what made him want to take it on.
We co-founded AstroForge with definitely the intent to mine an asteroid, but really we wanted to make critical resources on Earth available. And one of the only ways that we believe to do that is to go off-world and mine asteroids.
And you were working with Virgin Orbit in the past and also Bird. Does this sort of lend to what you're doing now?
Yeah, I spent a number of years at Virgin Orbit. My co-founder, Jose, spent a number of years at SpaceX. And, together we were in kind of the infancy of the satellite small sat revolution that we saw happening. And I think what we saw there was access to space dramatically decrease in price. And we saw quite a few companies take advantage of this. Things like, Starlink, OneWeb, a lot of these constellations going up, but we didn't see anybody really pushing the envelope and thinking outside of the bounds of Earth. And that's what we started to think about. What could you do if you could go outside of the bounds of Earth with this low-cost access to space?
that was a big idea of like how much, SpaceX and there's reusable rockets have transformed the ability to sort of reach further and do it less expensively.
Absolutely. We've also seen something else happen very recently, which is awesome. We've seen a lot of privatization or commercial companies going to the moon. And companies that are going to the moon allows us to have access to launch vehicles that are going to lunar orbit, which gives us a lot more energy to get out into deep space. As we announced, our second mission is taking advantage of this with Intuitive Machines. They're a company that is going to do a lunar lander. We're hitching a ride on their launch vehicle to get out into lunar orbit and then using that as kind of a leap pad to go out into deep space. Our first mission is sending up our refinery. So this is a prototype of how we expect to refine an asteroid in space. We're going to send it up and show that we can do the refining in low Earth orbit, right? In the confines of a vacuum with no gravity. Can we refine what we believe to be the surface of the asteroid? That mission is launching in April 2023, so we're about 3 months away from launch. That'll be on Transporter 7. And then in October, we are on the Intuitive Machines Launch 2. That is a Falcon 9 going to lunar orbit. And that will be the mission where we go out to our asteroid. We're going to take high-resolution images of the surface of our target asteroid, confirm it's what we expect it to be, in preparation for the follow-up missions that we have planned.
Wow. And so this first one is going to be basically to make sure that the refinery process works and that you can actually do that is the challenge zero gravity in this scenario?
I think the challenge is that nobody's ever done refining in space before.
Full stop, yeah.
And so, full stop, we want to do a world's first here. And what we plan on doing is sending up what we believe to be an asteroid. So it's a piece of iron with some other elements associated with it. Essentially, imagine a little rock. We're sending that up and it's going to be processed through our system. And on the other end, we expect to see platinum on the other side. And that's what we want to prove in the confines of space.
And speaking of that, Planetary Resources, I'm sure you know the name well, and Deep Space Industries, they're two former companies with similar aspirations, right? They wanted to mine asteroids, but they didn't survive, both through technical constraints and obviously the massive cost of this undertaking. But what makes what you're doing a little different in both how you're going to go about the problem and what you learned from their failures?
Yeah, both those companies were great companies, and obviously they started about 12 to 15 years ago now before us. First off, those companies gave us a lot of insight on what to do and what not to do. And multiple members of those teams are advisors to us or work with us full time. And it's been great to be able to tap into kind of that resource base as we stand on the shoulder of these companies before us to kind of go to the next place. But on top of that, their timing was very different than ours. As I mentioned, we can buy a rideshare slot to the moon. That was not available a year ago, let alone 10 years ago, right? The cost and access to space was just not there for them. And I think that was the critical problem with both of those companies.
To that end, can you paint me a picture of how the launch, the actual mining itself, and the whole process would work as much as you're willing to share, I'll say?
Absolutely, absolutely. So we leave Earth aboard a standard rocket, and I don't even have to put a company name on it. It can be a SpaceX rocket, a Blue Origin rocket. It really doesn't matter to us. We'll buy a rideshare slot on one of these rockets going out to orbit around the moon. We will leave from the moon and we will travel out to our asteroid. We land on the asteroid and we spend about 3 months on the asteroid refining the regolith into the platinum group metals. And then we store that on board the spacecraft. We bring it back to Earth. The journey back to Earth will take us about a year. We'll use the atmosphere to slow us down. We'll land and we'll recover the resources and sell them to a final refining.
When I was speaking with the OSIRIS-REx mission, they talked about the regolith, that they sort of kick it up, and the idea is to get this stuff into their net or into sort of like a sieve so that they can grab the pieces they want to grab. Obviously, you have some proprietary technology, but is that the similar sort of process, or are you looking to do this in a whole new way?
We're looking to do this in a whole new way. Now, keep in mind, we're going to a very different type of asteroid than OSIRIS-REx went to. OSIRIS-REx went to an asteroid called Bennu. It was broken up. It was determined to be this rebel pile. I think it was a really cool kind of shock for the science community when we all saw it, and something that everybody really leaned into and was awesome to see. For the scientific world, that was great. That's not what we're targeting, right? We are going after what we call M-type asteroids, believed to be the former core of planet that was disintegrated. That's one of the theories here. That's what we're going after. So a very different type of asteroid than what OSIRIS-REx went after.
What's your gold standard? What are you hoping to find on these asteroids that would be most beneficial back here on Earth?
Yeah, it really is those platinum group metals, those 6 elements that are critical in everyday use cases we have. I mean, platinum is used in things like chemotherapy drugs. These are used in the catalytic converter on your car, all the way down to critical components in chip manufacturing, right? And one of the reasons that we had the chip shortage was due to the lack of platinum. So going after these is kind of critical to what we need to survive and maintain our standard of living. That's what we're focused on.
What do you see as the environmental impact of this?
Yeah, I mean, the big picture is this is a critical problem facing the world that I don't think we're paying enough attention to at all. Mining as a whole is responsible for anywhere between 8 and 10% of the world's CO2 emissions. And that's just talking about CO2, not the massive amount of big holes we dig or land waste we do or water waste we leave or tailings that are left behind. Like, these are very damaging processes. And on top of that, we are running out of ore. Specifically, when we talk about the platinum group metals, we are running out of those ore sources. And there's no way to make this, right? You can't make this at any quantities or at any industrial scale in a lab. So the way we need to solve this is to go where we know a ton of this metal exists, and that is in the asteroids that are floating around us in space.
This is also going to be a very, very lucrative experiment, right? I'm curious, I guess, about the economic impacts of this. If you were to bring back a ton of precious metals, there's countries in Africa that's their main export. South Africa, for instance, is the largest producer of platinum. It accounts for about 72% of the world's supply right now. It employs over 450,000 people each year. So what happens when that is displaced?
I think that anytime you disrupt an industry and anytime you're going to try to solve an industry for the betterment of the planet, there will be some people that are affected by that solving, no matter what you look at. I mean, we can look at the shift we've seen in ICE engines to electric cars. There's been some major hiccups in those kind of classical car businesses that have had change and pivot, and there's been jobs that have lost and people that have been displaced. It's a problem that we have to solve. And I would hate for it to displace anybody, and we'll see what happens in the long term. But I firmly believe that we are going to have to solve this one way or the other. And there's not an option. We don't have optionality with this.
The question I keep turning around in my head is the very nature of precious metal is the idea that it's precious, right? So when you bring it back and say we're flooded with platinum and other platinum group metals, is the value somewhat diminished or lost?
Our vehicle is not bringing back, 1 million tons per mission. We bring back a very small amount of platinum that can be sold in the market without really any disruption multiple times. And we're trying to figure out how we scale up our small missions in order to do that. Now, that being said, if we do get to the point where we're able to cost effectively bring back a lot of platinum, one or two things are going to happen. We're either going to see a decrease in the price of platinum, or we're going to see a myriad of other uses for platinum group metals. Similar to like how aluminum happened at the turn of the century, right? Aluminum was a very rare, precious metal, and now you wrap your half-eaten sandwich in it and put it in the fridge. It's a very different construct on how we think about it. And, I hope that we are so successful at one point that you wrap your sandwich in a sheet of platinum foil. Like, that would be an awesome goal to achieve.
When you're talking about trillions of dollars coming back to Earth, I mean, Neil deGrasse Tyson has said early and often, along with other astrophysicists, that
the first trillionaires will be those who mine asteroids, the resources of the solar system.
It's exciting, but it's also something to be mindful of.
Yeah, game planning this out, absolutely. It can be a very lucrative industry if you can figure it out at a business case that closes. We believe we have. But I want to be clear here, we're not in this alone. This is not for me to become a trillionaire. I don't see how that would ever happen. We've had a lot of venture capitalists that have believed in this mission and believed in what we've had to do, and we hope to show them great returns with it, right? And that's kind of how we've situated this company. But first and foremost, we have a lot to prove, and these first 2 missions that we're set out to do are really laying the groundwork for us to prove that.
What do you see as the realistic timeline when I might have a PGM in my catalytic converter or, in my phone that comes from a near-Earth asteroid?
My honest timeline here is that we are hopeful to launch our first refining mission and have it return to Earth before the end of this decade. And that is what we are planning on doing now.
Matt Gailich, thanks so much for your time today.
Awesome. Well, thank you very much, Vicki. Really appreciate you having me on the show.
We'll talk about where all this is headed after the break. As we've been hearing today, there are ambitious plans in space, both for science and commerce. For a bigger picture, let's bring in Bloomberg reporter Lauren Grush, who covers this booming industry. Lauren, gotta say, this is a really good time to be a space reporter. There's just so much going on. We're gonna go back to the moon. Maybe we're gonna go to Mars. We're gonna mine some asteroids. What has you most excited right now about all of the stuff that's going on?
Well, I think for the last few decades, the focus has been primarily on, launching satellites, communication satellites into low Earth orbit or to geosynchronous orbit. But yes, there's so much promise on the horizon, and there's all these big, bold ideas, and people are starting to put money behind them and really try and prove them out. And also NASA is showing that it wants to cultivate these ideas as well by giving out development contracts for bigger, bolder, more interesting things in space, such as going to the moon.
Let me just ask you about the moon, because we've been there. Why do we want to go back, other than that kind of prestige a country gets from landing people on the moon?
Well, I think prestige is a big part of it. Also, NASA is making a big case that we need to go as some kind of race with China. For instance, the NASA administrator made a case that perhaps China could get there and claim territory or, try and claim resources up there. I don't think we're anywhere near that level yet, but, prestige and seeing what we can do is part of it. The case is also being made that we don't want to go there like we did during Apollo. We want to go there sustainably, so to see if we can live off the land and have a somewhat permanent presence on the moon so that we can practice for going to Mars someday. And then, in tandem, NASA also wants to cultivate this lunar economy by having private companies develop capabilities to get payloads and cargo and people to the moon as well. So NASA doesn't want to go alone. It wants to bring a whole host of companies with it.
So one of the other big things that's happening now is something that we're talking about today, this idea of getting resources off of asteroids. Vicki's spoken to people at OSIRIS and AstroForge, as we heard. You also spoke to the CEO of AstroForge. How does that strike you as somebody who reports on this? How plausible is this that this becomes like a real thing?
I approach it with some level of skepticism because there was kind of this, what I call an asteroid mining boom, I guess, about a decade ago. Two notable companies, Planetary Resources and Deep Space Industries, both made these big claims that they were going to go and mine asteroids and make this thriving industry out of it. But ultimately, that kind of went bust as they both got acquired. So it is an interesting time for this company to be focused on asteroid mining, since most are focused on going back to the moon with the Artemis program. So we'll see how it goes. They do have a lot of promise. I think one of the things that stuck out to me from talking with the AstroForge CEO is that they are focused primarily on creating their own refining technology. So they say that since they can focus primarily on doing in-space refining, that's what will make them successful. So I'll be very interested to see if that plays out the way they say they will.
One really interesting thing that came out of the conversation Vicki had was this idea that you can just hitch a ride on a rocket now, whereas you couldn't do that before. You could rent space on a rocket, which seems to be a really big development, not just for asteroid mining, but for anyone who has designs on doing anything in space. How big a deal is it that SpaceX, Blue Origin, other companies like that are making trips outside the Earth so accessible?
Well, there's a whole market for small satellite launches. So I think the main point is there's options, right? There are these smaller companies that are focused on small rocket launches that can be kind of like a dedicated, tailored launch. Or you can buy space, like you said, on a SpaceX rocket where they cram on a bunch of all of these small satellites in what are known as rocket ride shares. So they can pick and choose which is the best for them. And it doesn't necessarily break the bank because they're not having to buy an entire rocket launch. They can just buy space on it.
So how much does it cost if you want to participate in a rocket ride share? Love that term. And you want to put something on a rocket. What do you have to pay?
We're certainly not at the point where you and I can just throw whatever we want onto a rocket, but it still costs millions of dollars to get, a satellite into space. But it's on the order of a few million versus, tens of millions of dollars.
Another thing that seems to be a really big development is a reusable rocket, that it doesn't just go up, get destroyed, and some little bit of it parachutes back down, but it goes up and it lands where it took off. is that really critical for this idea of being able to do more serious commercial ventures in space?
Well, whenever we deal with going to space, the biggest cost prohibitor is getting there. And for decades and decades, it has been an extremely expensive endeavor just to break free of Earth's gravity and get into orbit. With reusable rockets, they're in pursuit of just lowering the cost of getting to orbit as much as possible. So when those costs comes down, it makes it more accessible for other companies like these small satellite operators, these startups, to get into orbit for a cheaper cost. But for now, it still is millions of dollars to get satellites into orbit. And that still will be, I think, a barrier until we can get it down even lower than that.
You said that one of the most expensive things about going to space is just getting up there. And that's something that also came up in Vicki's conversations, where in mining asteroids, there's this idea that if you didn't have to carry all your fuel with you, all that weight, but you could somehow refuel on top of an asteroid using the resources available there, that would be a great leap forward in space development. It seems like science fiction, but these are serious people talking about this in a serious way. How far off do you think something like that actually is?
Well, that's also one of the reasons why NASA and others are so interested in going to the moon as well. So one of the things they cite is the fact that we know that there's water ice on the moon. And the thing is, we don't know how much water ice is on the moon, but ultimately the idea is water has the components for rocket fuel. So hydrogen and oxygen. And if you were able to break it apart, you could use those components and rework them so that you can refuel your rocket. And that way you don't have to actually bring all of your propellant with you, which has been one of the biggest problems when it comes to going into deep space, because you have to carry so much on your back just so you can make it back home. But we are still quite a ways off from actually knowing if that is even possible. So we're sending the first robotic spacecraft to the moon, hopefully this year. We have a Japanese company called iSpace that is on its way to the moon right now. We have two US companies, Astrobotic and Intuitive Machines, that are working on getting to the moon just to see if they can land on it intact. But then we're also hoping to send a prospecting mission to kind of see what the water ice is like on the moon. That's called Viper in the next few years.
Lauren, we're talking about all these amazing things that if we had said, we're going to do this stuff, 10 years ago, it wouldn't have even seemed plausible. When you look 10 years ahead, maybe even just 5 years ahead, what are the things that really sort of get your attention as especially exciting or innovative that are going to be coming our way?
I think some of the things I'm most excited about are spacecraft that stay in space and do details there. So as we mentioned, getting off of Earth is so difficult. And so this idea of creating an in-space infrastructure is really exciting. So for instance, having so-called space tugs where you have spacecraft that remain in orbit and push your spacecraft to higher orbits or take them to different areas that they need to go. In-space manufacturing. So rather than building everything on the planet, like we did with the James Webb Space Telescope, and we had to launch it folded up because it was so massive and complex. Instead, we build it with materials that we send to space. That way you don't have to actually do this kind of crazy origami when you launch it. And then also when it comes to living and working on the moon, I've been very optimistic about the longevity of the Artemis program, NASA's return to the moon, because it's survived multiple administrations at this point, which is, I think, quite incredible. I mean, space takes a while to develop, and so we need consistency if we're actually going to do these long-term programs. But there's a lot on the horizon to be excited about, and so I'll be definitely watching with interest to see what succeeds.
Lauren Grush, thanks for coming on the show.
Thanks for having me.
You can read more from Lauren Grush at Bloomberg.com. Thanks for listening to us here at The Big Take. It's a daily podcast from Bloomberg and iHeartRadio. For more shows from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen. And we'd love to hear from you. Email us questions or comments to bigtake@bloomberg.net. The supervising producer of The Big Take and the producer of this episode is Vicky Vergolina. Our senior producer is Catherine Fink. Hilda Garcia is our engineer. And our original music was Leo Sidran. I'm Wes Kosova. We'll be back tomorrow with another Big Take.